All right. Hello and welcome to another learning lab, again with Patrick joining us today. He's going to talk to us about AI-based images and, of course, in the fray that's out there with everyone using AI and vibe coding and running MCP servers and all that sort of stuff. There's a lot of complexity, but a lot of fun things to happen and things to learn. So Patrick has been in this field for quite a long time and is going to have some fun memes as well, of course, I hear. So you should be hanging out.
Fun slash annoying slash,
That is with memes, right? Like,
cool.
no, but that's awesome, Patrick. We're really looking forward to your demo. Just a quick shout out as well. We just earlier this week had a product team meeting and webinar where Aditya, Angela, Mark, Mandy, and Sam talked about all the recent features in things like the Docker file connector, the custom assembly, Chainguard libraries for Python and console improvements, the chainwork command, whole bunch of very interesting stuff. And that's now on YouTube. So make sure you listen to that out and have a look at that if you're not sure yet what Chainguard will offer you. Obviously, there's also the website for stuff to learn about. And we will see you again for another Learning Lab next month. Topic yet to be determined. But today, Patrick is going to talk to us about AI-based images, hardened containers. There's a lot of complexity in this and should be super interesting. If you have any questions, please do chime in on the Q&A chat and let us know how it goes, and we'll have a session of questions and answers towards the end. And with that, Patrick, it is yours.
Manfred. All right, I'm going to share my screen, switch over. So welcome to the Learning Lab, AI with hardened container images. I'll just talk a little bit about who I am, what Chainguard is. My name is Patrick. I'm a staff developer relations engineer at Chainguard. I live in Queens, New York. And I'm one of those guys who likes to, sauna and everything as much as I can. And when I'm not doing that, I'm hanging out with my wife and kid here. So, and I love Python. I love building stuff with and without AI. I love working with data. And lately I do kind of love vibe coding a little bit and vibe everything. It's not just coding, but it is a little bit addictive. I'm sure some of you are doing this stuff. So this is, before we kind of dig in, and we'll talk about this, but some of these images are pretty beefy boys. They're big, okay? So let's prepare yourself, okay? And but if you have Docker installed, then go ahead and do a Docker pull now, and then you'll be all ready by the time the demo rolls around, because this thing can take a little while to pull down. I think it's going to be somewhere in the realm of 4 or 5 gigabytes. And then we will need a environment with Bash. You'll need tar and curl, and you'll need Docker. Okay, and I haven't tested this on Windows Subsystem for Linux. If you try it there, drop me a line and let me know how it goes. It should, in theory, work, but cool. You won't need a GPU-enabled environment for the demo. Okay, we will be doing some training and inference, but you won't need a GPU-enabled environment. Cool. So Chainguard, Linky. This is our octopus friend Linky. He represents Chainguard, and who are we? Who is Chainguard? We are the safe source for open source. We are dedicated to supply chain security. And we love to raise the waterline on security, so not just stuff directly related to our products, but when we work with our customers, when we create more educational materials, work with the community, we're all about making everything secure. We come out of a lot of great security and DevOps projects. So our founders have worked on things like Kubernetes, the Salsa project for signing, SigStore as well, which many of you probably heard of, and Google Distroless as well. So we're going to get right into it. So the CVE system, some of you like, okay, I've heard of CVEs. I'd work with CVEs every day. Some of you are like, CVEs, that's an acronym. I don't know what that is. So CVE, it's common vulnerabilities and exposures. And this is really, I would say it's the bread and butter frontline defense for dealing with known vulnerabilities, for dealing, basically it's a giant The CVE system works. There's a giant database of vulnerabilities that is kept by NIST and other organizations, and anyone can look at those. And there's a whole ecology of tools built around the CVE system to scan any software artifact to see if there are known vulnerabilities in there. And we got Michael Jordan in Space Jam here. He's saving us from the vulnerabilities. So but unfortunately, like I said, anyone can look up a CVE. So once a vulnerability is known, it becomes urgent to patch it, because not only the good guys, but also the bad guys can go up and look up CVEs, and they can use scanners just as well as anyone, and they can scan your production application and see, oh, it's vulnerable in this way, this way, this way. So it actually does become fairly important to patch your to remediate. Let's just say patch. We'll talk about that in a minute. Remediate your CVEs, and not just because of security, but also there's a lot of good compliance reasons you're going to need to do this. If you want to work with the federal government, for example, the U.S. federal government or the Canadian federal government, or a lot of other governments are adopting these systems, you're going to need to eliminate your CVEs within a certain amount of time, which can be difficult. So what do you do if you are running, say, a container image that runs Ubuntu in production, say on your Kubernetes cluster, and your boss comes to you and your boss says, hey, we're going to be working with a client that doesn't want a CVE in this they want CVEs remediated within a certain period of time, or there needs to be under a certain threshold of CVEs in this container. So now you've dealing with what I call boss assigned me to fix Ubuntu problem, okay? And you're going to be unhappy like this guy. That's because a lot of the CVEs are contained in the OS, not just the OS, the language runtime, and you basically anything you're building on, any of that infrastructure you're building on, language runtime, applications, and the OS is also a big source of CVEs. So all right, there's definitely ways of dealing with this. The traditional way is you get out a team of engineers, get out your spreadsheets, start itemizing those CVEs, what you got in there, and then just start coming up with ways to deal with them. And we'll talk about a little bit about what that kind of looks like in a little bit later, especially with us, maybe not less the traditional stuff. Now, another thing you could do is you can adopt Chainguard containers. And what Chainguard containers are is we start all the way left. Okay, we don't shift. You may have heard the phrase shift left. So but we actually start left. So we start all the way upstream, and everything we do from building our Chainguard OS to building upstream projects, which are all bleeding edge, is done with the specific goal of having low to no CVEs in our containers. Okay, and that's what we have. So when I joined Chainguard, I was like, 0 CVEs. It's nice to say. It sounds kind of fake, and we actually, we see a lot of skepticism about this online, and I think it's kind of justified. And I feel like that's kind of my attitude when I came into Chainguard. And I was like, maybe it's a trick. Maybe it's like, oh, a Tuesday, one time they had 0 CVEs, maybe whatever, Now, we actually do this, get down to 0 on most days, on most of our containers. Not always. Sometimes there's a few in there, and I'll show you some charts in a second. Actually, let's look at those charts now. So I pulled, and this is a cool thing, I think. But we have our Chainguard console. So if you work with us, you can also just create an account, even if you're not a customer. You look at the Chainguard console, and what we have is it will show the CVEs that are currently in our containers. It also shows a lot of other information, but among other things, it shows the CVEs currently in our container, the historical CVE data, and then it also compares it to the most comparable upstream. Okay, so I pulled PyTorch here. We're going to talk more about PyTorch in a minute. But PyTorch, it's a big image. On the left, you're seeing what we have currently, which is, currently we have 0. You can see in June we're carrying a few, I think like 4 CVEs or something like that for a period of maybe a couple of days before they got remediated. And then PyTorch is more in the realm of the hundreds, with a bunch of criticals. So And I also just took a quick look at the Python one too, because I know, most of us probably think about Python using Python, or at least in some fashion, or something comparable, Node or something like that. And yeah, Python's somewhere in the hundreds here, carrying some criticals, and we are, we had one or two, I think, earlier in the month too. So there's a little period there, and I think those are probably mostly the same overlap with PyTorch, those CVEs. And you can see here, the little line on the bottom is actually us. So it doesn't look like anything. It just looks like a flat line here is actually us. And this is the upstream, how it's changed over time, and then how the new ones that are being found. I know are also pretty low down there. Okay, so back to the deck. So how do we do it? I think is how people then ask us. And if you want to get the really short answer or the 4-letter answer, it's toil, hard work. It's another 4-letter answer. And it is hard work. And actually, I would recommend, if you're interested in this or interested in technical aspects, you could go online. We have a series called This Shit is Hard that we've been posting. And we have some other great content. But let's go into a little more detail about how we do it, other than just saying it's hard and we just do a lot of work. But that is basically the secret. It's like there's no one trick that we do. There's a few, I think, good decisions that we've made, which I'll talk about. But it is a lot of hard work that we do in and out every day. And we've hired some great people in this area, and you guys can't have them back. We have them now at Chainguard. But we have, so this is kind of, or a little bit of philosophy of how we do things. But basically, we try to be minimal, right? If you're going for 0 CVEs, you start wanting to strip out as much bloat as you can possibly can. We take that very seriously, and even to the point where we have variants of our standard variant of a container doesn't even have a shell, doesn't even have package managers. Okay, you have those available to you. We always have variants where those things are available to you. But that's what we kind of push people toward, is to not have those things in the production version of the container. You can use them in development. You can bootstrap the environment using those tools, but then we recommend not using them in production. We try to be fresh. Okay, that means we build. Everything's on the bleeding edge. Okay, and we have what we call the Chainguard factory. It's chugging away right now, building upstream projects. The second somebody commits some code, we rebuild it within the Chainguard factory, and then it gets brought into our containers overnight. So everything is crispy, fresh. It's in the crisper there. Nothing's sitting around for weeks, months, whatever. And we'll talk a little bit more about that later. This is a little bit of a weird one. People don't talk about it as much outside of Chainguard. You heard a little bit. We issue a lot of advisories. We have great relationships with this huge ecosystem of scanners. I think we're up to like 15 or 16 scanner partnerships that we try to work closely with. And we try to advise them on what affects the containers and what doesn't. Okay, and we have a pretty good feed. You can check out our advisory feed and get a kind of a feel for how we do that. And then finally, little odd man out. This is the thing. He's kind of the weirdo in the Fantastic Four. We do patch, but we try to avoid it. We're not into patching really so much at Chainguard. Okay, we try to prefer to just be bleeding edge, do these other things, and the patch is the last resort, and we don't do it that often. Okay, so let's talk about AI now. That's basically what we're here to talk about, AI. So before, whatever I've said before kind of applies to all containers, but AI presents some specific challenges. Okay, and I would say many or most of those challenges, not all, but many or most of those challenges come from the fact that these containers tend to be huge. They're enormous. Okay, so they're gigabytes in size. They have tens of thousands of executables. They tend to have some huge, enormous number of packages. So they're just, I'd say, maybe more than an order of magnitude larger, maybe multiple orders of magnitude larger than your standard language runtime or whatever container image. Okay, we got our little Dark Souls meme with AI containers is the big guy, and containers is pretty intimidated by that. There are some non-AI ones that are somewhat comparable, but mostly not. AI containers tend to be some of the biggest ones. They have a lot of shared objects, archive files, and just a ton, kitchen sink full of packages and everything tend to have. So I'm going to pick on one image here, and it may not be fair just because, I could have talked about TensorFlow. I could have talked about other AI frameworks, okay, that are also quite enormous, okay. Nemo is one we've built, and it's even bigger. It has kind of PyTorch and then a bunch of other stuff. These are all great frameworks, but they're upstream the containers that you will find online for them are enormous. They're kind of I'll just say they're a little bit bloated, okay? So let's dig in a little bit to, and this is Wayne's World. All my memes are kind of dated, okay? But we're shocked by some of these facts that we're going to unearth about PyTorch. We already looked at the chart with the CVEs, and that there are hundreds, in some cases pushing up to the 1,000 number, and pretty much always carrying some criticals. This is another kind of dimension you can look at. And we don't really look at files. You know, sometimes people are like, oh, there's files, or just the absolute size. I mean, size matters a little bit for convenience and for running things in production and so on, and for not using up all your resources. But mostly, I think executables and packages give you a little bit of a sense of attack surface. Packages, because any package can become a CVE over time. Packages times time equals CVEs, equals known vulnerabilities. Okay, so that does matter a little bit. And the PyTorch container has something in the I think it's something like 240 something packages. We have 130 something packages. Okay, and in terms of executables, they have something like 1,300. It's in the 1,300s. It's like high 1,300s. And then we have something like, I think it's around 390. I think it's actually 390 currently. So we have, I would say, significantly less attack surface in our containers, even beyond the obvious CVE thing. So I think we're gonna now jump into doing a little demo. And if you take a second, hopefully maybe you downloaded that big container image, you know, deleted some photos off your hard drive, you know, downloaded that big container image to your hard drive. We're gonna run an image classification. We're gonna fine tune a model, ResNet 18, to classify between 3 categories of images. I'm just keeping this slide up on the, I have a slide for this, but I want to make sure that you guys get this link. So this is the go links .chainguard.dev/AI-LL. So that's AI-Learning Lab, AI-LL. Okay, and you can pull this up, and we have a little repo that you can, basically we're going to copying and pasting 3 commands. I'll be stepping you through what's going on in the behind the scenes, but I tried to make this a little bit of a relatively straightforward path. So what are we going to be doing? We're going to be doing some image classification, and with 3 categories of images. So we're going to do octopuses for Chainguard. You know, we have Linky, Docker for containerization. We've got Docker Whale, and we've got the classic Linux Penguin Tux. Okay, we're going to classify this model that we're training. We'll classify between 3 sets of these 3 classes of images. Okay, and it'll tell you any image. It'll try to say octopus, penguin, or whale. Okay, and let's go to switch over. So if you go to that link, and I'll just show it one more time. It's golinks.chainguard.dev/AI-Learning Lab. Okay, so make sure you pull that up if you want to step through this. This is the repo that will come up there, and there's a little bit of explanation for you, but basically what we've got here is a training command, then a curl command to download an image. It's an image of an octopus, and then finally we have a command to run some inference. Okay, so we're going to use the model that we trained and check that image and see, is it an octopus, is it a penguin, or is it a whale? Okay, and a couple of little facts about this. So first of all, we have links up here to the script, to the image and everything. So I would say, you know, it's good practice to, you know, it's tempting to just run these commands. I would say we're pretty trustworthy. We're a security company. Reputation is our bread and butter. However, it's good to get in the practice of taking a quick look at these things and just doing a quick gut check, okay? And so when you're running any arbitrary code in your machine, so it's going to run a PyTorch script to train, and then it'll run the same script with different inputs to do the inference, okay? So let's copy this first command, okay? This training command. Now I will say this is running on CPU, okay? So I will be using a GPU-enabled environment, but I'm going to be doing the same as you guys running on CPU. Okay, that's just because I figured people probably wouldn't have a GPU-enabled environment necessarily sitting in front of them. Okay, so this will run Go ahead and I pasted it. So I'm going to go ahead and run this, and then I'll talk a little bit about what it's doing. It probably will take slightly longer than we want to sit around waiting, but we'll see. We'll see how long my little speechifying lasts here. So what this is doing is it's grabbing a little data set with the three classes. It has training and validation data for the 3 classes of images. So it has 6 folders, into 2 categories, training and validation, and it will train and then validate using the validation data. I think it's something like 66% is training, 33% is validation. And these are pretty small because you've used something like Resonate 18. These are really great base models these days, and you don't need to fine tune that much. You're almost just providing suggestions. And I did a little bit of testing, and actually it did pretty good with actually very few images. I'll also say these are all realistic images, so you have the option to download your own image and see if ones work online, if you grab a picture of a penguin or something like that. But don't get a picture of a cartoon penguin because it may not, it's more likely to mess up since we trained on realistic looking pictures of penguin. Now I have to make a gut check here. We're only up to five epochs out of 25. So I'm gonna do the classic demo thing of, being like, okay, pretend this finished because I ran it earlier. So I'm gonna cancel it. But you go ahead and let it finish, okay, on your machine. So if you're running it, let it finish training, okay? I'm going to cancel it for the interest of time. I'm doing Control-C on it, and then I am going to remove that folder that we created. Doing RF commands on camera is always fun. All right, so I'm deleting that folder that we had, and I'm going to use the one that I already had that finished already. But it should be the exact same thing. I just did the exact same thing early. And I'm renaming it to image classification. And now I'm going to download the image here. So if you look at this little curl command here, okay, we're going to use this. And we're downloading the thing. And if you want to see what this image looks like, I'll just, on my host machine, I'm going to run this curl command and then open it in my image. Okay. So it's a picture of an octopus. He's kind of cool looking. And octopuses are cool. I do personally. So it's downloaded it here in this environment. And now we're going to finally go ahead and run our inference. Okay. So I'm going to copy this, and we're going to run this. Fingers crossed. Octopus. Okay, so it successfully identified that image as an octopus. And I have tried this with a few other things. It does seem to do the penguins and whales and everything. Okay. I even fed in. You can even do weird things. I love playing around with how these classifiers work. You can feed in like a picture of a toaster and be like, is the toaster more close to being a whale as far as this model is concerned? I don't know. Maybe I'm weird, but I find that kind of stuff interesting. But let's go back and chat a little about some of the developments that we've had in this sort of like Chainguard AI containers program. I hope those of you who are still training, your fans are spinning, you're training a little bit. Hope it all works out for you. In that repo that I shared, there's a little link to, or you could just go in and create an issue in that repo, but there's a link, to create an issue in there. So if you ran into an issue, ran into a problem, you tried this out on WSL, go ahead and open an issue in there. That'd be great. If you follow this QR code, you're going to go to our AI containers, Chainguard AI containers, and learn a little bit more about those. I'll just say some highlights from what we've been working on recently. There's been a lot of activity in this area, and I think they were awesome. Now they've become even more awesome. But a couple of things that we've included are now we have all versions up to the upstream stable. Okay. The NVIDIA upstream stable. So you can go up to 2.7, PyTorch 2.7, for example, and you should be able to run on the latest versions of CUDA. And we have introduced compatibility library support. So if you have, which is fairly common, if you have to run on underlying on a host that has drivers that are kind of specific, which is a very common scenario, you can use these compatibility library libraries to use newer versions in production. And a couple of other things is, yeah, we build stable, not the most bleeding edge. What upstream is considered stable. So I think we're about ready to. Oh yeah, I just also wanted to say what other cool containers we have, because we are highlighting PyTorch here. PyTorch is our most popular AI container currently. We now have TensorFlow available, which is popular. We have the KServe family of inferencing containers, which are a lot of our customers have been using and enjoying, and we have a whole lot of I would say, if you check out our directory, we have about 15 AI containers currently in our AI category. So I would recommend going and checking those out. And also, so the one I wanted to mention too is the Torch Triton and all the various backends from VLLM to Python we have available, and there's been a lot of interest in those. So I would definitely recommend checking all of those. PyTorch is the one that we have that's publicly available that you can play around with. But reach out and let us know, and we can start talking. So I think we're about ready for Q&A. So I'll switch over, and this is Wolfie, which is the smallest octopus in the world, and our open source OS that Chainguard OS is based on. It's called Wolfie, and it's a very minimal OS. Okay, so we named it after the smallest octopus in the world, and he's going into a little hole here, and he's only the size of half of a fingernail. Okay, so he is tiny. And there's actually not that many videos of these guys. I was looking for, this is the best one I found. There's not that many videos of this guy. He's pretty elusive. So, and also I've got my LinkedIn here as a QR code. But Manfred, you want to help us out with some Q&A?
Yeah, awesome. That was great. Lots of cool memes for sure, and also very great introduction for Chainguard. So thank you for that. There is one question in the chat, and that is leaning towards something we'll have to talk about anyway, and that is, how is that? Is there any support for NVIDIA-based NIM images?
NIM, I think we don't currently have those supported, but I will. If there's interest, reach out, and I think we're always looking to decide which containers to build next, and we have NVIDIA Toolkit and a bunch of other sort of like plumbing containers. But if there's interest, we will build it typically. So, great one.
Yeah. Also,
anything else in the chat?
There's no other chat questions, so please do in the audience do chime in with more questions. But I do have some. So when you use these containers, often you need to download a model or whatever else, that kind of stuff. You can just continue downloading that on your container and then build a new custom container, I'm assuming, right?
Yeah, exactly. So you can build on top of them using whatever you prefer, Docker files. We also have custom assembly now. So if you need specific, say, for example, packages, we have custom assembly, which will help you to, and say you're a customer of Chainguard and you need say our Torch Triton image, but you need 3 packages that are not standard in that container. Okay, so you can use our custom assembly, and then we will basically set up a version that you can pull from our registries, or you can mirror to your own registries that will have those packages set up for you, or you can use your familiar Docker file and build on it that way. Okay. Oh, so and also we have certs. We have insert too. So people do sometimes ask about certs. So we have a specific tool to insert certificates too.
Yeah, that's obviously important when you run it on your own infrastructure for security reasons. So that's important to have. So when you run these things, typically, where would people run them typically? Do they run them in their own Kubernetes clusters with special hardware, I'm assuming, or what's your experience?
Yeah, I mean, it depends. I would say that's a very common way to run these containers, and they're designed from the ground up to run well on Kubernetes. We also, in the wild, we see a lot of customers building these like kitchen sink containers, and we definitely try to push people or gently suggest that people use these more specialized containers with orchestration rather than building like large kitchen sink containers. And so we definitely encourage you to use sort of like modern orchestration tooling such as Kubernetes to run these. And the environment that I just showed you was a GCP instance where I was kind of running things in a very simple way. But now with these, if you run latest, which if you're trying them out, that's what you will be running. They were actually a little more bleeding edge than the standard GCP deep learning instance will support. So you may have to kind of like set up your own Ubuntu with some of the latest drivers. But if you're a customer, you can pull any older tag. You can use different versions, and you can also use those compat libraries. So.
That's cool. And typically you run them on a cluster. So a lot of those tools are set up to run in like a parallelization cluster with like multiple nodes and all that kind of stuff already, right?
Absolutely. Yeah. I mean, it could be, and these are very scalable. If you say use a KServe or something like that, like KServe is designed from the ground up, and this is another popular family of AI containers that we have built recently. And if that's built from the ground up to run in Kubernetes, and to inference at scale. Okay, so and it would be, I think, I'd say if it's KServe, most customers are running it on Kubernetes or some other similar environment. And then but I've seen a lot of use cases out there. There's a lot of ways to use container images. I've seen a lot in the wild on how folks use stuff, and I would love to see more folks prototyping and stuff with these. So if you're doing that, let me know. If you're a data scientist and you're messing around with our containers, let me know.
Yeah, no, that's super interesting. So, have you seen we just also recently announced that we have the Helm charts for our container images. Is there any coverage for the AI images there, so you can orchestrate those things with Helm charts? Or is there anything on the horizon for that? Do you know?
This is probably one I'm going to mulligan on. I was just looking at these to test that the Helm charts that we have in our READMEs and stuff work, and they do seem to work. But other than that, I wouldn't say I'm too much of an expert on it. But we do have support for them, and so I haven't used them I haven't messed around with them in like a production simulated environment. So I don't think I could go too deep. But we do have them, and they do seem to work in my testing. So.
Yeah, no, that's good. Like that's good to know, right? Like people that are like, well, how to get it into this cluster? Well,
that's how you get it into the cluster. Yes. I just haven't played around with them recently, but yeah.
Yeah, so no mainly running kubectl control commands with lots of configuration files.
Hey, you can do whatever you want, and I also was just chatting with I think Dan Lawrence just mentioned this or whatever, but you can vibe kubectl, you know what I mean, and see how frontier models do setting up your cluster. Maybe not one that's already working, but if you're playing around, if you're prototyping. You might be surprised at how far you can get with some of these newer tools or whatever. So
yeah,
but yeah,
you might even get all the way to having something like Helm.
Well, yeah, who knows? Convergent evolution.
Yeah, exactly. No, that's good. Awesome, cool. Have you seen any like super interesting use cases for these AI models yet from our customers, or anything we can talk about there?
I mean, definitely inferencing seems to be a big, and both are sort of, I would say, like base GPU enabled images, which are sort of like the PyTorch images, but a little more stripped down, and which are basically, it's a CUDA enabled environment for you to do whatever in. Or PyTorch images, and newer things like KServe are great for running inference at scale for lots of customers in like a reliable way that your infrastructure is not going to be vulnerable. Because I would say inference is that's training, depending, it depends on your use case. But I would say in the median use case, training cannot be a sort of like special snowflake, you know what I mean? And you can have it off to the side. And then inference is where the rubber meets the road, and that's where you actually need to have everything be secure. So so I would say take a look at these, especially if your organization is running inference for customers at scale, or there's something happening behind the scenes for customers, and you don't want your infrastructure, your web apps, whatever, to be vulnerable.
Yeah, and obviously you also don't want like the data spilling across from different customers to each other or that kind of stuff. So there's lots of security controls to be put in place for these kind of flow. So it's good to
and
see
I have a
that.
talk on some of the other elements of the non-CVE related elements of running production AI workloads, and that's a talk called "The Old, the New, and the Strange," and it's another pretty weird talk where we play a little game, but we go through all the modern ways that models can be shut down, hijacked, corrupted, and it's kind of a fun one. It's a little bit silly too, but we cover a lot of ground. So.
Yeah, I saw that talk. It was very interesting at the sample. So thanks for that. That was also a great shout out. You'll have to do that again sometime. All right, cool. I don't see any other questions. No one is chiming in otherwise. So anything else you want to mention? Obviously, people should go out and try this out with our company.
I'll just plug our course, which is, check out, if you Google Chainguard AI course, we have a course that covers basically the whole soup to nuts AI ecosystem, including things like compliance. We also do some of what we just did, which is like running models. We dive deep into scanning and the scanning ecosystem. So I think that's a great course if you're kind of spinning up, and maybe you have a DevOps background, you want to go a little deeper in this area, or you're just curious. And it's a great for getting up in a bunch of different areas related to putting AI into production in 2025.
Awesome, cool. Well, that's a good last tip. With that, I would say keep an eye out on our events page on chainguard.dev for upcoming events. One of them is going to be a bunch of different customers talking about their use of Chainguard, which is really interesting. So maybe register for that virtual tech talk day. I forgot the name of it now, but that's coming up soon in, I think, the 20th of August. So you have a month's time. And then, we'll have another learning lab and other events coming up as well. So always keep an eye on our website and our blogs. The series you mentioned